In Algebra 2, Section 4.4, we're dealing with complex numbers. So basically what we're dealing with here is you're going to be dealing with square roots when you move on to the next two chapters. And unfortunately, when you plug in a negative in the square root, you can't, there's not a number that exists. For example, if I have the square root of 4, well, I have to find two numbers when multiplied together that gets me 4. It could either be 2 times 2 or negative 2 times negative 2. Both equal 4. So the square root of 4 would be plus or minus 2. Now, if I have the square root of negative 4, there's no two numbers when multiplied together, no two of the same numbers when multiplied together gets me a negative number, because if I do negative 2 times negative 2, the negatives cancel out and become a positive. So that's the reason why in the calculator this doesn't exist, but you will still get it in equations. So what we're going to deal with here is what happens when you do. And because of that, we're going to deal with imaginary numbers. All right? So what happens is, if I have I squared, so this imaginary number squared, I'll get a negative 1. So the square root of a negative 1 is I for our imaginary number. Right? So if I have the square root, okay, and I subtract, in order to solve this, I'm going to minus 64 on both sides. Then I square root both of these. I end up with the square root of x squared. This and this cancel out. And then I have the square root of negative 64. So, because no two of the same numbers multiplied together gets me negative 64, I can do a negative 1 times the square root of 64. This square root negative 1 turns into an I, and that way I can do the square root of 64 as 8. So my answer for the square root of negative 64 is 8i. So it's the same thing that you're going to be doing with all the square roots that with square roots that you've been dealing with, in Algebra 1 and geometry. But this time, if you see a negative, separate the negative so that it'll become an I, and then you can deal with the square root itself. So let's look at this. We have the square root of negative 28. So I can make this the same thing as the square root of negative 1 times the square root of 28. Well, this becomes an I right here, but let's take the square root of 28. The square root of 28 is the same thing as the square root of 4 times the square root of 7 times the square root of negative 1. Don't forget that negative 1. Well, I can't square root 7, right? But I can square root 4, so that would be 2. And because I can't square root 7, I'm going to leave it there, so 2 square root 7, and this becomes an I. So one more time, in case that was a little too quick, I separated. I took 28 and I factored it, right? And I have 4 and 7. If I have other factors, I'm looking for the one with the square root inside, all right? Not square root, the perfect square. And since 4 is a perfect square, then I can go ahead and take 4 and square root that, and then 7 will be left over. The next one is the same thing. I'm going to do the square root of 32, and this becomes, the negative 1 becomes an I. So then I can take 32, and I'm going to factor it. Okay? It's the same thing as 8 times 4 and 4 times 2. Well, I can automatically, because this is the same thing as square root of 4 times 4 times 2, anytime I have a square root, I can take something out as long as I have the same number in the square root. 2 numbers in the square root is the same thing as 1 number outside. Just like when we did 27, right? We have 4, 7, 2, 2. So this becomes the square root of 2 times 2 times 7. Because I have 2 numbers, 2, that's what gives me the perfect square of 4. I can take a 2 out, giving me square root of 7, and that's how I got A. So I can do the same thing with 32. I have 2 sets of 4. Okay? If I didn't, I'll keep going until I find 2 sets of things, if there are 2 sets of the same number. And so because these 2 in the square root represent 1 on the outside, this 2 is still left on the inside. and then I have an I. So my answer is 4 root 2 I. When I multiply, I can treat an I just like a variable. So when I multiply and divide, I can multiply and I have to add the exponents. When I divide, I subtract the exponents, if you remember those rules. So you treat it just like an x. And then when I'm adding and subtracting, I can only combine like terms. Okay? So I have negative 3i times 2i. So this would be negative 6i squared, right? Negative 3 times 2 is negative 6, and then I times I is I squared. Now the thing is, I squared equals negative 1, so this is the same thing as saying negative 6 times negative 1, which gives me a positive 6. Right? On this one, I end up with, this will give me a square root 12i times a square root 2i. And 12i, if I factor 12 out, I get 4 and 2 and 2 and 2. So I have square root of 2 times 2 times 2i times square root of 2i. All right? So I have a set of 2 here, okay? And I also, these combine together, so what I can do here is I have, this is the same thing as square root of 12 times 2i squared. See how that works? And 12 turns into 3 2's. So 1, 2, 3, and I already have a 2 from here. So 4 2's I squared. So I have one set of 2, and then another set of 2. And then the I squared becomes negative 1, so my answer is negative 4. I hope you can see that. Sorry. The answer is negative 4. This one, it wants us to solve, and what I'm going to do is I'm going to isolate the y squared. So I'm going to subtract 20 from both sides. I end up with 5y squared equals negative 20. I'm going to divide both sides by 5. Okay. And then I'll end up, this cancels out, I end up with y squared equals negative 4. And now I square root both sides. This would be y equals negative 4i, which is the same thing as the square root of 4 is 2i. And that's my answer. So go ahead and pause, write it down. Remember, I can treat my i's like x's. So if I multiply them together, they become, we add the exponents. If I divide them, we subtract exponents. And anytime I have an I squared, it's equal to a negative 1. So go ahead and pause, write this down. I have one more board for you, one more concept to go through before we're finished. Okay, so in this one, they want us to find a solution. Now this is pretty straightforward. All I need to do is put the i's together and then put everything else together. For example, here's my I, positive 1i and negative 3i. So I'm going to do equals 3i, right? And then I'm going to do 2x minus 14. 2x equals minus 14. So I do this side with any number that doesn't have an I, and this side with only numbers. So I'm setting like terms equal to each other. Because I do this, now I have two equations two equations that are a lot simpler to solve than this. So now I'm going to solve for x here. I'm going to divide both sides by 2, and then negative 14 times 2, x equals negative 7. And that's my x. My y, I'm going to do the same thing. I'm going to divide, because you see how I is attached by multiplication, I'm going to divide by I. This cancels out, and these also cancel out. So I end up with y equals 3. And that's my answer. So go ahead. Oh, we still have one more problem. So the other one is similar to this. I'm sorry, not similar to this. The other one is we're not actually solving. We're just we're just simplifying because there's no equal sign. And what I need to do is I need to treat it just like an x or a variable. So I'm going to bring this down, take this side, I'm going to distribute. So -3 and then plus 7i. Okay, then I'm going to combine like terms. 4 minus 3 gives me 1, and -6 plus 7 gives me positive I, or 1i, doesn't matter. So my answer is 1 plus I. So go ahead and write this down. This concept is a little bit more easier than the one we did prior, but go ahead and write this down. Try page 250, numbers 4, 7, and 14. Page 250, numbers 4, 7, and 14, and I will see you in class.